These are notes 5.6, talking about the standard normal distribution. In 5.55, we did a little bit of this using 68, 95, 99.7 rule to get the probabilities. We'll review that a little bit again. We're going to find the area from a z-score, and I'll show you the table, but we're going to use Desmos instead of using the table. And then we're also going to find the z-score from a probability, work backwards. Okay, so frontwards and backwards using some math there. Okay, so why are normal distributions important in science, statistics? Okay, so normal distributions are used a ton. Okay, so you really got to make sure you understand these things in statistics. First, they're good descriptors of distributions of real data. So if you look at scores taken by many people, okay, like the SAT test or IQ tests, all of them have a normally distributed curve where this is kind of like your average people, and you get smarter and smarter. There's fewer and fewer people as you get smarter and smarter, right? Most people are just average. Also the other way, there's fewer and fewer people that don't have the intelligence of the average person, okay? So looking at tests, if you take measurements of something, like the diameter of a tennis ball, it's not going to be exact. Every time you measure it, there's a little bit of error. Okay, so most of the time, most of your measurements are going to be somewhere around the true measurement, but sometimes you might be off a little bit more and more. Okay, but the farther you get off from the real measurement, the less likely it's going to happen, right? Okay, biological patterns, such as lengths of crickets and the yields of corn in a field. Okay, all these follow these normal distribution pattern. Okay. Also, it's good approximations for results of kinds of chance outcomes, like the number of heads in many tosses of a coin. Yeah, so we've seen them throughout the whole year so far. We've talked kind of about some normally distributed things. Okay, so looking at this rule, remember we reviewed this yesterday. We said that 68% of the people fall within one standard deviation, one below and one above. We said 95% fall within two standard deviations, two below and two above. And then 99.7, which is almost everybody, 99.7 fall within three standard deviations. And we broke that up. So if it's 68 in two sections, divide by 2 would be 34 each. Okay, from here to here is 95. 95 minus this middle part, 68, gives you 27. Divided by 2 gives you 13.5 for each one. And from here to here, 99.7 minus the 95 in the middle, divided by 2 gives you 2.35 for each of those. And then if it's 99.7, you know there's another 3% out here. Divide by 2 gives you 0.15% on each side. Okay, so we talked about those distributions there. And we talked about how you can find areas. Okay, so less than 3.74, so 3.74, we want to add those areas together, right? Okay, if we want to find something greater than 3.47, you find 3.47, it's greater than there, so we find those areas there. Okay, now, so we talked about that the other day. So new today is we're going to talk about a z-score. Okay, so notice here, we had mentioned this right here, how many standard deviations away it is called its z-score. So if I'm one standard deviation away, that's a z-score of 1. If I add the z-score in twice, that's a standard deviation of 2. If I subtract the z-score at once, it's negative 1. Okay, so those are my z-scores. And the formula, we did this earlier this year, the z-score formula was whatever our value is minus the mean divided by the standard deviation. Okay, so if it's a standard normal distribution, that just means that it's based on z-scores. So I have a z-score of 0 for the mean, a z-score of 1 or negative 1 if I add or subtract one time, z-score of 2 or negative 2 for 2 times, and z-score of 3 or negative 3 3 times. Okay, so when it says the standard normal distribution, we're looking at the z-scores. Okay, so we figured out how to find, like, if it's exactly on one of these numbers, right? But what if I have a z-score of, like, right here? Okay, so let's say this is at to find this area, okay, or to find this area, it used to be that people had to use a big table, okay, and this is what that table looked like. Okay, you have one side here for the negative z-scores, and you have another side over here for the positive z-scores. Okay. Now what we're going to do is I'll show you how to use this, but I'm going to show you how to use Desmos for it instead. So for example, let's say I get a z-score of 0.35. Okay, and I want to know the area. So what's the probability that my z-score is less than 0.35? Okay, so I want to know this area right in here. So what I would do here is go to the z-score, 0.3, and then go over here to 5. So 0.3 and 5. My probability would be 0.6368. So this probability here would be that area, that probability would be 0.368. Okay? And you could find any probability, right? Up to, it goes all the way up to a probability of 3.409. Okay? And then the other page would be the negatives. Okay, so what I'm gonna do for you here is I'm gonna show you how to do that on Desmos. Okay, so these are the 3 z-scores we're gonna look at. Okay, so I'm gonna do this on Desmos. So remember, z-scores are how many standard deviations I added and subtracted, right? Okay, so greater than negative 1.78. So 1.78 would be about here. So we're gonna find this area here for this one. Okay. For this one here, negative 1.25 would be, here, I'll do these in different colors. Let me use the same graph though. So this blue one here, we're going to use, right, we want to find all that area here. This one here, negative 1.25 to 0.81. We're going to find that area right in there. Okay. And then third one, less than 0.45. Okay, 0.45 would be about right here, and we want to know less than that, so we're going to find all that area in there. Okay, so I'm going to pause this, go to the other video, and show you how to do it on Desmos.
Okay, so to do these normal distributions on Desmos, you click here to get under Functions, and you go up to Distribution. And remember where we found the normal distribution the other day? Right above that is the binomial distribution. Right above that is the normal distribution. So we're going to hit our normal distribution. And if you click that little thing there, it gives you a nice little graph, okay, to zoom fit. Okay, so it automatically does the standard, so the z-squared. So notice we have 0, we have -1, -2, -3, and 1, 2, and 3, right? So it automatically does that. Now, tomorrow we're going to talk about how to change that, and we can put in here a different mean and a different standard deviation, but that's for tomorrow. For today, we want to find the cumulative, so the area from here to where to where. So right now, it's going from -infinity to +infinity. So -infinity down here, all the way up through +infinity up there. We want, okay, so the first one was our z greater than 1.78. So our minimum would be -1.78, and our maximum still goes to infinity. Now, you can either put infinity or just put some large number like 9999. It doesn't matter, okay? So what it's finding is this z-score right here at -1.78, and we want greater than that. So these are the numbers greater than that. So that area there, that probability is 0.96, okay? And then the second one I showed you, we want to go between -1.25 and 0.81. Okay? We're going from there to there, and it finds that probability for us to be 0.69 if we round it. Okay, and the last one, less than 0.45. So here I want to go some large negative number, and all the way up to 0.45. So 0.45 and less, right? Less than 0.45. So that comes up to be 67%. Okay, so Desmos makes this very nice for us so we can see the picture and we can just type it in and get our answer without having to use that table.
Another thing we want to talk about, our third goal for today, is to think about if I'm given a certain area or probability, what is the z-score associated with that? Okay, so you could go to the table, but I'm going to show you how to do it in Desmos once again. So let's find the probability z is less than what z-score is about 90%. Okay, so what we're doing here is if I have 90% area right here, what is the z-score associated with that? Okay, So to do that, I'm going to pause the video and show you on Desmos how to find that. Yeah, so I'll show you how to do that.
Okay, so for the inverse, this isn't quite as nice as the other one, but this is what you do. So take notes on it. Okay, you hit here. You first have to identify what kind of function it is. So we're still talking about the normal distribution, and it's a standard. So we're using 0 and 1 for our mean and our standard deviation. So you can see the picture here, right? So our mean is here at 0 with a standard deviation of 1 going both ways. Okay. Now, what we want to do is we want to find the inverse. We want to go the opposite direction. So we're going to have to put dot and then come down here, and we're going to have to do the inverse CDF right here. So inverse. And then we can put whatever we want in there. So we had said we want the z-score for 90 percentile. So we're going to put 0.9. And there's the z-score for it. So I know if z is less than 1.28, it'll give me 90%. So if I kind of show that here, I'll show it the other way. So normal distribution of 1.28, right? If I want to know the area from -infinity to, whoops. Hold on, let me start over there. Okay, so if I go to normal distribution, still going to use a 0 and the 1. I want to go from -infinity to 1.28. You can see that it's about 90% right there, right? And if I type that whole thing in, it would give it to me. So this is how you go backwards. So if you're given an area, you type this in with the probability there, the area, and this is how you can find it from the z-score to find that area. Okay, so that's what you have to type in.